Hi there. Thank you all so much for coming this afternoon. My name's Del Harrow. I am an associate professor at Colorado State University, where I teach in the ceramics program with my colleague Sanam Amami. It's really my distinct pleasure this afternoon now to introduce two really remarkable people and artists and their talk today, Grant Landreth and Camille Friedman-Gerlicz. Grant and Camille are both currently special students in our program at Colorado State. And unfortunately, as artists, they're a little bit too good, so they're going to be moving on to graduate school, both to really amazing graduate programs next year. Grant and Camille and I all met. Grant, Camille, and I all met a few years ago at Anderson Ranch Art Center. I was teaching a workshop there in digital fabrication. And we met there, and I think really immediately had a really strong connection in terms of our shared interest in tools and processes and thinking in different ways about those tools and processes. And I've felt for a long time, I'm teaching at a research institution, but actually beginning to teach through digital fabrication tools, that it felt like there was a real possibility, both in institutions of these kinds, but also particularly through these particular tools, to work in a way that I think is more collaborative than maybe what many of us, how many of us typically work in our own studios. To work in a way that I think is modeled by many of the other disciplines working in a large university. And this has always felt like sort of a possibility more than a reality until Camille and Grant started working in our program. And I feel like in the time they've been at Colorado State, we've had the opportunity to work now on a number of projects together, which have felt truly collaborative, that there's truly a kind of shared authorship and a kind of collective intelligence, where the whole becomes greater than the sum of its parts, and we can sort of work together to begin to address problems in toolings and problems in tooling and problems in research, and sort of move these questions much further than any of us could do on our own. So it's really been a pleasure to work with these two, and I'm so excited to see them up here on the stage at NCECA, and it's really all of our pleasure, I think, to get a moment to see what they've been working on. So please join me in welcoming Camille and Grant.
So sweet. That's so sweet. Great. Thanks, Del. Okay, so we're going to do a presentation today that's going to kind of outline some of the things that we're doing at our lab at CSU, and then a couple of things that Grant and I have done in our individual work using the resources we have, and then we'll end with talking about this project that is really a group project between the three of us. So these pictures are actually all from that summer that we met Del at Anderson Ranch, and it's Del doing a little 3D printing. And I was super excited meeting Del. I have a background in math, but then I decided to go into clay, and so when I met someone that was using technology and math and that kind of side of the brain with clay, I was just really, really excited to go study with him. So I went to CSU, and the first thing I did was I got to TA Del's digital fabrication class, which turned out we were in collaboration with Allegheny Meadows. He had bought a second art stream. And the whole class, we had 7 students, and the class was to learn Rhino, design, and then build the interior of this second art stream, which was a huge task in one semester. But we took it on, and it was so fun. This is our class. I think at the end, we kind of look happy about things. I think this is the last day, maybe. The first thing we did was the first project kind of to learn Rhino was to get the students to model the art stream in an unfoldable way, because that's kind of the aluminum can unfold if you look at it. I mean, they do some pressing and things like that. But so this is a little bit of just our sketches and then modeling and then laying it out there. And then we water jet cut a 4th scale model. So the trailer's 20 feet, and we water jet cut out a 5-foot long arch stream and riveted it together. So there's Dell and I riveting it. And then we went to work on the interior. So we're trying to build some shelving system to display pots and artwork. And this is just a screenshot of kind of a workflow in Rhino. And this was also part of something that we all were learning at the same time with the students, kind of how to do this collaborative thing, but yet not pass a file off and one student changes something and then we don't have any record of what happened before. So to get the students to, we had all these files on a Google Docs and just like figuring out how to work with about 10 people's hands in this project. We had a couple students that really took on Rhino, which was the program we were using, and got really, really good at the modeling. So we were asked to put humans in to kind of see what it would look like inside that space. And if any of you guys have been up, this is the art stream that's upstairs in the exhibition hall right now. And this is really what the interior looks like. So then there we built a 4th scale wooden model for the interior. And then in the last week of school, we busted out the full scale model. And so there it is in the unfinished art stream at the very end. We installed it, and then there's the finished art stream, and then there's a show up there right now of all digital fabrication work.
It's the art stream 2.0.
2.0, yeah.
Exploring the digital landscape.
Yeah. So there it is. There it is with the tiny 4th scale model inside. So part of that, this is the first time I'd really done any woodworking in any significant way, and we have this really awesome lab at CSU, and I was kind of inspired by learning all these things, and I really wanted to dive more into the programming part of it. And I'd kind of heard about Grasshopper, which a few people...
we both kind of heard about it when we took that workshop.
Yeah, when we took that workshop, totally.
Like, what?
Yeah, we were like, this is so cool, and it was so mysterious, but I kind of had this idea of, after seeing what we were doing with the art stream, of doing kind of a shelving system, a big wooden unit. So I kind of just had a project and took on Grasshopper and wrote a definition to build this kind of waffle structure and build it specific to the space. So this is a scale model. And then I made it big, and we took it to our CNC. So this is one of our 2 CNC mills at CSU. And then I installed it in our computer lab. So I think one of the coolest things that Dell has built at CSU is we have a really great open computer lab that is attached directly to our room with our laser cutters, which then is attached to the wood shop. So it has this really natural flow of like purely digital to very, very concrete and mechanical. And I mean, I use that a lot. And for me, the computer has become part of the studio practice. So there was like a question earlier today about the disconnect between the virtual and the physical. And if you're not touching clay, how does that work? And for me, even like clicking of a mouse in that computer program like starts becoming a physical part of my studio practice.
And I would also say, like, one really great thing about this lab, there's a lot of things, but it's like functions also as just like people wanting to check their email. Mm-hmm. And I think it's not like this sort of standalone thing. Like, people really feel welcome and get used to that space and the hopes, and it really does sort of translate into them then like progressing further, that it's not like this, it's just like all one big open thing that everyone's welcome to be a part of.
You can see all the screens, so if someone's working on Rhino and doing something cool, another student can come up and ask. It's a really great space. So I built this wall that permanently is in that lab right now. So this is the next project, or another project I worked on at CSU. And so for me, what I was really interested in using this digital fabrication is that I have this math background. And of course, as soon as I left the math world and joined the art world, math kind of creeped into my work in a pretty big way. And so the technology and the programming kind of allows me to find the complexity and the precision that I'm looking for in my work, and then use it to achieve that. So this was a project I worked on that I was researching these algebraic surfaces. So that equation up there creates this surface. It's called Gorsat's surface. And it's like you could hand build that object or come to that form on your own, but I was really interested in it being this thing that is defined by this equation, and so it's these constraints. So I took that object and I basically sliced it in 2-inch chunks and then encased it and made a foam mold. So I don't have any pictures of the milling, but I milled just 2-inch pink foam and then stacked them all on top of each other to do a press mold. And so those are the pieces that came out individually. So the pieces don't have any marks of the tooling, but I used the digital fabrication and things that I could only figure out through a computer to give my piece the form that I wanted. And then it all came hanging together. And that's actually the piece that's also upstairs in the ArtStream show right now. And then the last little quick project I'll talk about that I'm working on is just doing some mold making and other modeling. So I'm working with still some functional work and interested in these cups that kind of tessellate and fit together. And so one side bulges out and the other side bulges in the same way. And I actually made a physical model of the bulging out that fit perfectly in my hand and then took it to the scanner and scanned it in and then used that to then piece together this Rhino model. And then the bottom picture is just how you might unfold a 6-part mold using Rhino. So I modeled it completely, and then I went to the mill and milled my plaster. And then there's my mold all cleaned up. And there's a couple different molds I've made this semester. And then I'm going to throw it over to Grant to talk about what he's been doing.
Yeah. Thanks, Camilla. So my background, I have an undergraduate degree in architecture, and for about 8 years I worked in the historic preservation field. And so I sort of took a ceramics class, and then all this sort of, like, you talk about math just like finds its way back in. It's like this sort of other stuff finds its way back into my work. And I would do these sort of site visits and evaluate properties and like what things could like be changed and what had to stay. And I would always look at these materials. Often bathrooms are considered secondary spaces, and this sort of like 2-inch by 2-inch tile is sort of the ubiquitous sort of middle 20th century material was everywhere, and it was just like, but like no one really noticed it. I don't think anyone really cared. It's like sometimes feels really ugly to people, or it's institutional. But I sort of think about those things in my work. So, and it's also something it's readily available at like Home Depot. And what you don't realize is like, it seems like really slick, but there is like a surface to that glaze. And so one photo, I just scanned it and then sort of like enhanced it, showing like the surface texture. And I mean, in my work, I'm thinking like, how do I use this technology in a way that I guess pertinent to like the material, whether it's like ceramics, but like how does that sort of like, I guess like feed, like there's got to be like a different level of information, like some sort of like poetics to it potentially. So I mean, this was like one goal was just to like figure out this whole grasshopper thing. And there's this really great tool where you can take an image and within the definition, and it'll just sort of like create a surface. Which is like a really simple thing within Grasshopper, but I thought it was like a great opportunity to take this texture, the surface that goes unnoticed, and then maybe represent it by using the material itself. So I just sort of used that definition, created a surface, basically like using that 2-inch tile to like basically represent itself. And so that's the image that's the rendering of the surface I created in Grasshopper, and then those are the tiles, and I subtract them out. And then really, I think, digital fabrication, like this whole process, like it allows you to really kind of not only think about well, of course, content and the material and all these other things, but like how are you going to install this stuff in a space, and like really try to integrate it into the form. So even something as simple as like integrating a cleat into the wooden structure to make sort of like a seamless sort of installation on the wall. And I guess like another thing, like this image, I took it one night. I was having a lot of trouble. Like I modeled this thing, did all this grasshopper work, and I was still having trouble they called non-manifold edges. Like it was like getting these like surfaces to like be perfectly aligned. And so I felt that was interesting, that it was like this additional layer of labor in the process. It's like, I mean, like, I think a lot of people, and I think this is maybe this whole workshop that we've done the last couple of days has maybe helped people realize that this isn't like an easy thing to do. It does take, it's just all in here. And then eventually it comes out in the material and maybe back. But it's like I was doing all this work, and then there's this other level of like having to go in and like move the surfaces so they're like perfectly aligned. And I just found that like really beautiful that that there's this additional level of labor already, and then how could I represent that in the work? And I ended up just putting a simple glossy glaze over the already standard tile to kind of just indicate that. And then these are just quick images, like just made a simple like waffling structure off of that whole surface, and a little detail. And then I think another thing, I mean, so Del and Camille would warn me, I think this is the first time I'm like, just do all this stuff, that, you know, you think like, oh, I'll just design this thing, and like the structure's gonna fit together perfectly well, because it's a computer made it, but it's not true, because like I think it's every CNC, every machine has its own eccentricities, and you have to really figure out the tolerances specific to that machine. Yeah, so you do testing to make sure that this stuff is all going to fit together. So that's what this is, and then you just lay it out and I guess mill it like I don't know. You just always find like things along the way that things don't work out the way you wanted, and you make it work. But yeah.
That's our second CNC mill. We just got it up and running. A nice, really big. It's really awesome.
It has like a greater level of like it's like a tighter tolerance.
Yeah. It's more accurate. Maybe I think is the right word. Mm-hmm.
So yeah. So that's the final sort of art that is the image of the one tile. So okay.
You want me to go again?
Yeah.
Okay. So that's kind of a little just some projects we've worked on, and then we kind of. You know, Del was invited to do the Fab Lab, and he kind of brought us in that collaborative energy that he was talking about. I mean, is really amazing, and it's so generous at CSU. But it was like the three of us kind of came in, and we kept batting ideas around, like what if we did this, and tar paper and molds. But we were all three of us actually were milling plaster this semester, and so we thought, why don't we do something like that? And the idea was fairly straightforward, like start with a geometric shape, a hexagon maybe, and maybe just make like a tower with that. And I don't know, something like that too, I've learned that it's really nice to start, like, you know, it's really just a formal decision, and that, you know, there's not a whole lot of major concept behind it, but then it kind of like gives it all this room for play and exploration and change and adaptability that I really enjoy in that collaborative process. And that part where it's not really like the authorship really is between the three of us, and so no one is getting their feelings hurt if we don't like an idea, or if something changes, and no one feels so attached. And I really like that part. I felt like with this project we were really able to just like kind of say, what if we did this, and then try it, and then if it worked, great, and if not, great. So anyway, so we started with this cylinder idea, and then we said, okay, well, how can we kind of make it more dynamic and interesting and generate some forms? So we had this idea of like a bowing out and a bowing in, and so I'm going to go through a little grasshopper definition later, I think, about how we did this. But basically, we just took a rectangle and pushed it in six ways this way, so in increments of 6, and then out 6 ways, so that gave us 12 mold parts. And then we wanted more mold parts, so then we added a level of faceting to both the in and the out. And that gave us 24 parts. Right. And then we were kind of all doing a bunch of milling with plaster, and the process is slow. It's like you go into first you have to do all the computer work, and then you have to figure out, okay, how big does my plaster block need to be? And then you go into the plaster room and pour that, and then you wait a full day, and then you go to the mill, and it's just like this really intense process. And the idea of doing that for 24 individual blocks was kind of horrifying. So we kind of decided we need a better way. We're going to try to figure out a system. And this is what I mean. It was like the next step. Like, okay, what can we do to make this easier? And we decided, oh, well, all the angles of these things are going to be the same. And if they're really flat, we don't really need keys to get these molds to fit together. And so then we kind of just came up with, oh, we could laser cut some wood as kind of custom coddle boards. So we went to the laser, oh no, that's not even this one. So we're gonna laser cut this wood out, and then Grant had this awesome idea of like, okay, that'll be like these sharp corners. What if we could mill something or make something that would give us a mold strap holding area? Yeah. And so we kind of thought about what that shape would be, and then we went to the computer and modeled it and said, oh, if we 3D printed in plastic a little shape and then poured our plaster over we'd pop that out, and that would be where our mold strap would go. And it was kind of also a fun opportunity to use yet one more machine in our lab.
Yeah, we were like, I don't even know if we lined them all up if it would work, but it totally did, like
totally
on the
worked.
bed of the
Yeah.
3D printer.
Yeah.
And there's something really nice about like using this technology, not as like the final product necessarily, but like a way to like make the form work or this how to structure it out, and then like, I don't know.
Like being able to kind of custom make our own tools and kind of one-off tools too. Like it was all very cheap and easy to do.
Yeah.
I mean, not easy, but doable. And so then we laser cut these out. We laid them out in a big sheet and just laser cut, 1/8" plywood. And there's us gluing them all together with those the little plastic bits. We made little peg holes. You can see actually, it's on the floor. We'll grab it later. Little holes that those plastic keys would fit into. And then we went to, this is just normal plaster process. So now we went to our plaster room and poured a bunch of plaster and got everywhere. And then we cleaned up our molds. And this part was like, actually, I don't know, I think it felt more meaningful and interesting than I had anticipated. But it was this thing where we had designed that initial thing on the computer, and then we realized it physical, but when you laser cut, it's all two-dimensional curves. But then we said, okay, well now we have to go back and mill these 6 things on the CNC. And if we line this up a little rotated or this way or that or shifted, it's like maybe the first one will mill perfect, but by the 6th one, it's like off 1/8 of an inch or 1/4 of an inch. And so it was this thing of like, oh, now we like went to the physical realm, and now we have to go back into the computer and make sure we're modeling that thing like exactly perfect. And that was where we also used some Grasshopper, where the coddle board system was a Grasshopper definition, and one of the inputs was the thickness of the wood. So we had that down to, thousandths of inch of how thick the wood was going to be. So there's that. So we laid it out and we decided this is what we want to mill. And so we took it to our mill. And this was the process of getting the supports, the things that were holding our piece down perfectly level to the mill. And then we put on an engraving bit, which our shop tech was like, you guys aren't going to use that on plaster, right? And we said, no, don't worry. But we used a really fine point to center it like super, super exact. So that was really fun though, to just like kind of do this other level of going back and forth between physical and digital. And then we held our breath and turned the mill on and hoped it worked, and it worked great. This is us doing a roughing pass. And the nice part about our coddles too is that we were really taking away not tons of material. We weren't using so much plaster and having to just because plaster does get everywhere. Like that one looks a little messier, but then we went over a final pass. And then this is a different one. We threw it back on there. There's a little close up. And we could see little bits where it got off, but I don't think it ever got off more than 1/8 of an inch.
Yeah,
even that, like
and it didn't really matter.
Yeah, right.
Yeah.
And it was exciting to see. And then on the ones that bowed out, we needed higher wood, so we actually ended up milling through plaster and wood all at the same time, which was a little.
Which is like the first time.
I had done that.
Yeah, it was like a little. Can we do that?
Yeah.
Why not?
But we could, and we have an amazing shop tech at CSU who is like
big plug for Scott.
Yeah, really, really supportive, and just like makes an environment where it's like he makes sure everything is safe and you're doing things well, but that you're encouraged to explore and try things, which is really nice. Mm-hmm. But yeah, we popped our molds out of our coddles and took the little plastic pieces out. I guess they all kind of lined up, and they're all up there. But yeah, we're kind of getting to the end. Then it was like back to just normal things. Now we just had normal plaster molds, and they were all variable, and we could move them around. But this is us mixing slip at our studio. And then the last little thing, this is like the night before we left, I think. I was like, I want to use one more tool. So I went to the vinyl cutter, and we made a little labeling system. So the S is for smooth, and the F is for facet, and it goes in and out is the I and the O, and then it's 1, 2, 3, 4, 5, 6. Yeah. And so we vinyl cut out little labels, and I used them as stencils and Sharpied them and took it off so that we have a nice labeling system.
I think like along the way we were like, well, maybe we should, like if we were going to do it again, we would have, but it's like, we find ways to make it all kind of work.
Yeah.
And
yeah, so that's kind of the end of that part. I don't know, do we still have a little time in our presentation? We were just going to show just like how we were going to, the last little bit that we kind of decided to do, oh shoot, it's not zooming, for this project to generate it. So again, kind of just like this whole thing was just to kind of explore what we could do and how we could push these materials that we have spent a lot of time learning and have some sort of fluency, not like absolute, but we feel fairly comfortable with some of them. And so the last thing we decided to do was write a little grasshopper definition that took all the pieces and then randomly built form for us. So instead of us deciding and making aesthetic decisions, we decided to let the computer make those decisions for us. So there's our labeling system there, and we have a little labeling system there. And then I can just slide this, and it'll generate random forms. And so the last thing we were going to do maybe before break, I think we're on number 5, was to generate a form and then start building it and slip casting it.
Yeah.
That was it?
Yeah.
Anything else?
Any questions?
Any other questions? I mean, we'll keep working, and I think I'm going to try to do a little like more in-depth grasshopper demo, either now or after the break, when maybe while our mold is drying. I think that was the idea. Just show like a really simple one, kind of,
Oh, we got a question.
Yeah.
Could you talk just a little bit about CNC milling the plaster? Like, are you doing it while it's still damp so you don't get dust?
Yeah.
Are you using a diamond bit?
No.
What kind of?
I mean,
Little specifics.
the bits that we use, actually, you can use, it can be really dull. So often, like, the ones in our shop have been used to mill foam, the pink foam or the blue foam, and that really dulls them down. But you can reuse those to mill the plaster, and you get really great precision. But definitely mill damp. I mean, you just sort of like pour the plaster, let it set up, and make sure it's cured. But other than that, you're fine.
Yeah,
and then if it's too dry, you make sure that you re-soak it. Yeah.
You can kind of see it's like you want it to come off in chips, and it does come off in chips. But it goes everywhere too. I mean, you have to have like, our shop tech is really generous, and he lets us.
Yeah.
Right, it's just the dust. Yeah. Yeah, we do like a pass with a 1/2-inch bit, usually a roughing pass, so we offset our geometry a little bit and pass over once. What are our feed rates? I think our router was going at our feed rate is like 50 inches per minute.
Yeah.
Is that what it is?
Yeah.
Yeah.
And then 16,500 on the router.
Yeah.
But it's like, it's not like if you're off a few, it's not going to matter. It's not like we're machining metal or something.
And I think, when we were going through it, we hit some wood, because we were hitting the wood, we slowed things down a bit, for sure. And, and then, and I mean, in our machine, the way we have a K2 that's actually really similar to that, but our router is just on there, and the dial for the spindle speed is right on there, so you can actually just go and change it. So we'll do and we do this with wood too, like you just listen to it and try to figure it out.
I mean, the facilities have allowed us to experiment in a way that I think, like some programs, like there's such a hesitation that you're going to do something wrong that you don't have that, like, we have Scott standing by, but it like allows you to like kind of just, what's going to happen? And we're kind of around to like make sure nothing bad, but like, I don't know. Like some programs just don't have that flexibility and that sort of like openness. It's really great.
Really, really, and just like an openness to teach about it too, and then let you experiment is really, really great at CSU. Yeah.
So I'm wondering, well, maybe not for you, I'm a math major, but what kind of learning curve did you have with Rhino and Grasshopper? Are they pretty intuitive in terms of the tools?
I think Rhino is fairly intuitive in a sense. I think
maybe we're a bit biased.
I think we're a bit biased. I do think I do find myself using some math things, but it's not like you need to. I think it's.
I mean, with Rhino, there's like a lot of the tools that you're using are like a virtual representation of like how you would make that physically. Like a turning thing like on a wheel or like lofting, like.
And little icons you can tell.
Yeah, totally. It's a pictures, and then like, Keith was talking about this earlier. You can type everything in. So I find Rhino like pretty intuitive to use. I think part of it is just it's like throwing, where the first time you sit down to throw, you watch someone do it, and it's like so smooth and they like look so great doing it, and then you do it, and you just feel like you're the most awkward person ever. And it's almost like that, but it's with clicking. And I think there is something, and I don't know, maybe this is like, I find this with students, especially who've kind of grown up with computers. Some of them are better at it, but they expect to be fluent with it immediately, and then it's really, really frustrating when they're not. And it is this weird thing where suddenly you like watch someone click around so easily and zoom in and zoom out and move, and then you can't do it. It's like, I don't know, I used to watch my brother play video games, and it was like that. I'd try, and I was like, God, I get so frustrated. But it's just like any other thing, you have to put the time in. And then, of course, it's like, this is a tool that has so much complexity. And so, I mean, I still feel like I'm 1% into it. You know, there's just so many layers that you can keep digging into.
I spent, for that project I showed, I spent like half the semester, like just going through tutorials on Grasshopper and like making things, but it takes some time. And maybe it's something that you integrate into your studio practice, but it's not like you're like, oh, I need to make this thing, and now it's just something that you sort of, it's a little bit more fluid, and you're doing other things at the same time. And that's like, you talk about complexity, like I think that's another thing that I think about. It's like this stuff, these programs will like create really complex geometries and shapes, forms, whatever, but it's like, you know, to what ends? Like, I mean, sometimes something like simple like what we're doing is pretty provocative in itself. Like, you don't really need to like have, I mean, you can just make really simple geometries and be not really proficient in Rhino and like create really something provocative. And yeah.
I also think that there's that thing, Andy talked about this yesterday morning, that like to get to this level of wanting to do it, it's just going to feel like math homework if you don't actually want to use it for your work, or there's not like a impetus if you're just learning to be like, I probably should know this program. But so for me, like, I can see what I could do with it in my work. Like, there's this desire to get better, so then that time that goes into it doesn't feel like a slog, basically. Like, you know, I think there's a little bit of that where you're like, I just got to buckle down and do this. But if it was all that, I would not want to do it at all, I think. Yeah.
Oh, yes, sir.
In the time of the talk, you said exploring poetics and using technology. Talk a bit about aesthetics here, and maybe talk about the weaknesses that you're sensing or seeing in the process. I mean, it seems like there are certain limitations to your aesthetic approach, in addition to the technical approach. So maybe talk a bit about that. What, so at this point, do you see as like, you know,
Like in our work or in the field or?
well, either.
I think just there's that hurdle of like when you first learning how to like work within like these sort of programs, like you can make an object, and it's like people have a tendency to make something super complex. I think that's a limitation. I don't know, like maybe not having an editor, or like questioning like, why am I making this thing?
I don't know. I think, like, you know, with the 3D printing, but like with the CNC mill, we're milling plaster and milling molds, where like the tool marks are there and they look really similar for everybody. And so, I don't know. I think about that a lot. Like, are you keeping those there just because it's hard to get them away, or like I think of someone like Andy Brayman is really taking control of those tool marks, and he is using the tool to make the mark he wants it to make in a really interesting way, I think. You know, yeah, I definitely think that there is that tendency of like, is everything just going to aesthetically look the same that comes out of these machines? I don't know. I mean, some of the things, you know, like some of the things, like that hanging piece that I made, I was really interested. It was a math surface. I wanted it to be really smooth. And, you know, some of the process came back out after the firing, but I took away all marks of the tool, or I tried to at least, because I was interested in that. And I think as long as people, I don't know, stay kind of conscious of that, and it's like that thing of, I don't know, just like intention too. Like, is this really what you want for your piece to look this way, or is there a way that you could do it so that it doesn't? Or what are you after? Do you want it to show that it was made digitally, or do you want that to be hidden? Or I don't know. That's how I kind of think about it a little bit, I think.
Any other questions? Well,
cool.
Well, thank you, everyone.
Thank you. Yeah.